Critique 4C in the linear data unit category is talking about lines of best fit. Students are expected to write with and without technology linear functions that provide a reasonable fit to data to estimate solutions and make predictions for real-world problems. I'm going to focus on the with technology section here, but a lot of these skills can be done by hand from the linear 2 unit that you can go back and look at. But what I'm talking about here, a line of best fit, is the slope-intercept form of a line that best describes the data. So we're just writing this form with a slope and a y-intercept, where I begin and how I move, for data points in the future. We're going to have some ugly tables that we're going to have to find residual points for. But using this line of best fit, the y equals mx plus b, that best fits this data, we're going to be able to make predictions for the future using it to create future outputs or y values. Now what this looks like, we might have a table of points showing up on a graph. This is again using Desmos. We want to write an equation in y equals mx plus b form. So we would write a y equals mx plus b annotated graph. So y1 tilde, which is the symbol, mx1 plus b. So it's y equals mx plus b with some annotation that allows the computer to do and run these residuals for us. And what it does is it tells me the statistics, the R value, or how strong this data is, and the parameters, which is my m, slope, and my y-intercept, b. So I'd be able to write a slope-intercept form line for this table just from this information. I look at it, and I get the m and the b that creates my y equals mx plus b format equation. These numbers right here, and these numbers go here. You do have to round because you're going to get some long decimals, and we usually round to the nearest hundredth, which is 2 decimal places. But that's creating your slope and your y-intercept via technology for these points that don't make an exact line that I can put a ruler in between. It's the best fit line, even though it doesn't really always fit perfectly. So let's see an example. It says a zookeeper recorded the feeding schedule for a baby rhinoceros for 20 weeks, and a scatter plot shows the percentage of the baby's rhinoceros's body mass that was used to determine the amount of food given at each feeding as a linear function of its age in weeks. Whoa. But we have a table, and we look at the question here, and it says, what is the best prediction of the percentage of baby rhinoceros's body mass that should be used to determine the amount of food at each feeding when it is 25 weeks old? Well, I noticed that weeks is my x, and that complicated body mass for the rhinoceros is the y's, or the outputs. So I need to create an equation that allows me to predict what would be matched up with 25 in this table that I don't have. Now, this is not a pretty pattern where you can just find the slope and continue the table. We're actually going to need to draw a line of best fit here. So we turn to our handy dandy Desmos, and we would type in the entire table to Desmos. To get a table, by the way, you're going to press the plus sign and a table, and you start typing away. But to get a line of best fit, we want to write a y equals mx plus b equation. If I just typed in y equals mx plus b, nothing's going to happen. I have to use an annotated version of these, which means instead of just a y, we would use a y1, because that's what my table is labeled. You see how the y1s are listed? There's y1. And our x is going to be x1, because that's what it is in the table. Now, instead of an equal sign, I want to use the tilde, which is found on the second page. If you click the ABC down at the bottom of Desmos, you have a tilde button, or there's a tilde on your keyboard, and immediately it creates a prediction for the future for me. This is the line of best fit that it's created. It would be y equals negative 0.54x plus 19.80. Getting those numbers down there from the m and the b, the slope and the y-intercept. Now, that's not what I'm really asked for here. I'm asked to predict what the output is at 25. Well, using your finger or mouse, you can click on the line and drag it up and down to see what the output would be along this point. So we want to know what it would be at about 25, and we get 6.15, 6.1. as our approximation for the output when we get close to 25. So if we go back and look at our answer choices here, we would see that we have an answer choice of 6 as an option. That's the closest prediction for the future that we got off of our line of best fit. Now, just like the correlation coefficient, I can use the graphing calculators that the schools provide to do this. I would use what's called StatEdit, and totally allowed to use that, totally agree, but it is not something that your student can take home and use. So we use Desmos as a means to be able to do homework at home. As always, we empower, we impact, we love. We are Skeeter Nation.